Hi everyone, thanks for coming. So my presentation is the lesson learned from automatic optimizing databases using machine learning in the real world. So I was a co-founder at OtterTune. It's a database tuning startup based on many years of research from Carnegie Mellon University. I was a student of Professor Andy Paulo, and we did research, and we did a startup together in 2020. But unfortunately, we just shut down company this year, and then I moved to OpenAI as an engineer. So today I'll talk about lessons learned from OtterTune, both from the technical side and the business side. So I will talk about background and the real world scenario, and the technical lessons, then business lessons. So background. So databases are notoriously complex to deploy, optimize, and maintain. So basically, you need to design your physical schema, indexing, partitioning. There are also many knobs to tune. For example, Postgres have hundreds of knobs, and MySQL also have hundreds of knobs. And I think the number of knobs also still increase over time. And you need to optimize your query. You need to provision your hardware. So right now, like many organizations resort to human to optimize that, but human expert are scan, unscalable, and expensive. So this is a survey of in 2021, it shows the average salary of DBA is like $96,000. But the real thing is that even you have lots of money, it's still hard to hire a professional DBA at these days. So then we can come up with the idea that can we automatically automate these databases. So automated database optimization, it has a long history of attempts in research and industry to automate database management systems. So in 1970s, it called self-adaptive databases. In 1990 and 2000, it's called self-tuning databases. And nowadays, it's called self-driving databases. So we published a paper in Cider in 2017 to describe self-driving databases. And later Oracle announced their first version of the world's first self-driving databases. So although they have different names, but the core idea is still the same. So it's to apply the machine learning to solve the tuning problem for databases. It's not only machine learning, it also uses the domain knowledge. Basically, you just want to automate these database operations using either domain knowledge or machine learning. But in the last decade, most of interest, there are lots of interest in machine learning because the advance in the machine learning, like neural network, etc. So in research and industry, in the last decade, also interest like using machine learning to automatically optimize your databases. Yeah, Microsoft has the OtterTune, Oracle, IBM, DB2. They all have the similar version of database tuning, automated database tuning. So there are different aspects of using machine learning for database tuning. So you can have the index tuning. I think Azure had their own version of index tuning. You have partition tuning, like Cloud Partition Divisor. You have knob tuning. So OtterTune, basically originally the research paper is for knob tuning. I think CDB tune, the Optimus, I think CDB tune is still there. So it's I think they are based in Europe or something. Yeah, this is a startup also based on years of research. Yeah, CDB tune is still there. Yeah, core tuning using machine learning like Ball, Neo. So I think the idea is that so pipeline is that given the database application, and you basically observe your metrics knobs, the collect from databases, and you use machine learning algorithm to learn from those workload pattern and the metrics you collected, and you train a machine learning model to predict what's the best behavior for the database performance. Yeah, so basically you continue to tuning and you continue to collect training data, and you apply the configuration, the recommendation, and you will learn from those patterns. So OtterTune is automated database tuning and resource optimization service. It's based on years of research at SMU. use machine learning to automatically optimize databases. We originally come from knob tuning, but in the commercial version, we basically support knob index query cloud configuration tuning. So we support Amazon, MySQL, Postgres. I mean, it's already shut down, so yeah. RIP, OtterTune. So yeah, the real world scenario. So I think we did many years of research, but we see lots of change in the industry is very different from we see from the research world. So one thing is that users basically do not maintain suitable staging databases. So in the research, we basically tune a capture workload and they have the basically similar they have good staging database. The staging database has the similar hardware and traffic, and with production database. So we capture workload and we tune on staging database, because the machine learning algorithm can sometimes make bad recommendation because it needs to learn from that, right? So we don't want to apply to this production directly, because if you algorithm apply recommended bad convolutions, it will be very dangerous for real production. So in the research, we basically tune on a staging database and apply to the, after finding the best configuration, we apply to the production database. That's the assumption in our research. But in the real world, basically, users do not maintain a suitable staging database. They do have a staging database, but the staging database is usually much smaller than the production database because of the cost, etc. And the workload, the traffic on staging database is much simpler than the production database. So which means even we tune the staging database, we cannot apply a recommendation to production database because the two databases are very different. So that's the first challenge we saw in the real world. Training models on staging database is bad because it's inconsistent workload and hardware between two databases. So basically, they usually run smaller databases, staging database because of cost. Yeah, so that's the first challenge we face. So basically, we cannot tune on staging database and apply the recommendation to the production in the real world. Another change is that user cannot capture a workload and replay them. So if you want to tune a workload, application workload, you need to capture them, right, and then replay them. But in OtterTune, it might not be true in a cloud provider because they have proxy, they can route the queries, etc. But for us, it's really hard to capture workload and then replay them. So without repeatable workload as a baseline, it's really difficult for machine learning model to learn and improve the databases. This is because of the tools of open source databases like Postgres and MySQL for capture and replay workload are really limited compared to the commercial ones like Oracle. Another thing is that we cannot log the queries, capture workload on database side. It's either to do in a proxy side, but we cannot control for that. And as OtterTune startup, because we don't have control on the proxy side, but it's really hard to do on database side. Although they have the feature to log the query, first query log. So basically, you can set the timeout to 0. So basically, we will log all queries. We did that once for one of our customers, but we basically increased our CPU usage from 20% to 99% because it needs to write all the reads query to disk. So basically, it's still down there production databases. So we just did that once. It's basically we want to tune their peak hours workload. So we choose the peak hour and we just did that and it just crashed their databases. So that's the sad story. But yeah, it's just the point that it's really hard to do that in the real world. Oh my God, we have only 10 minutes. Yeah, I will. Another thing, users mostly do now know what their database is doing. The production database workload is dynamic. So the idea is there is that, for example, if you have 20% improvement here, you really don't know whether it's because of, and before that or after that we apply a recommendation, it's really hard to know whether it's because of workload change or because of our recommendation change, right? So it's because their workload is always dynamic. So in the research, we just run TPCC, right? It always has a throughput there, but And if the throughput increases, it will know it's because of our good recommendation. But in real world, it's always dynamic. It's really hard to know where the change is because of the workload change or because of our recommendations. Yeah, so that's a start. So production database tuning. So I will go with the technical lessons first. So tuning a staging database using repeat workload is impractical because of the change we mentioned. But it's not practical in a startup. But it might be practical for the cloud provider because they can easily capture workload in the procedure. But as a startup, we basically cannot, because users do not maintain suitable staging database, and we cannot capture workload and repeat them. But the good thing is that the way we solve that is that we find that most customers actually allow us to carefully tune their production databases directly. Yeah, this is not an assumption we had before doing a startup. We saw it's really dangerous to do that, but in real world, actually customers allow us to do that. But they need to have control over what, when, and why changes are applied. So basically, it allows us to do that, but you need to do that very carefully. And they need to know what happened there, and they need to have a way to quickly revert the changes if something bad happened. And another thing is that customers really don't care about how fancy or novel your model is, right? Whether using reinforcement learning or deep learning or large language model, they don't care about that. They only care about how much benefit you can get and how quickly they can see the value, right? If you use if else something very simple, as long as it works, right, you can just use it. This is the difference between research and industry, right? In research, you need to come up with fancy model, but in industry, you really care about the benefits and the time to value. So as I mentioned before, user allows to tune their production database, but they need to have a fine-grained control over that, right? So they need to specify what knobs they want to tune and when the service will tune that. So basically, you need to allow users to specify tuning period. For example, they don't want to touch your production or tune your production data on weekends because it's weekend, right? They don't want something bad happen on weekends. And you also need to allow them to specify knob bounds, and then the scheduling and human in the loop approval. So basically, when you make a recommendation, they need to approve that first. They need to see your recommendation and approve that first. That's why the explanation of this recommendation is really important. They need to know why we make such recommendations, right? So it's really hard in the machine learning because from the machine learning model perspective, just use the model to train that because it's really hard to be expanded by machine learning. But users really need that, right? So we basically alternatively use some data-driven explanation or heuristic-based recommendation or explanation for that. But for machine learning, that's no issue. Yeah, so the idea is that you need to allow users to have fine control of the tuning, and the good thing is that they allow you to tune out the production database. But typically, you need to build some trust in the beginning. For example, they will use the human in the loop approval first. When you make a recommendation, they want to approve first. But after several days, after you see, oh, OtterTune is awesome, they just use auto-tuning mode, right? Because they don't need to approve anymore, just use auto-tuning mode. So the idea is that so usually I think after several days, customer just ended up with auto-tuning mode. They don't need to approve anymore. And I think that machine learning and domain knowledge. So you don't need domain knowledge. I mean the heuristic-based optimization approach, right? So they have pros and cons, and you don't need to actually pick one of them. You can use both. So the advantage of machine learning is that it can help find the nearly optimal database configuration. But the challenge is that there's no explanation about recommendation I mentioned before. And it needs some time to learn the patterns, right? So you need time to converge. But for heuristic approaches, you can, using the knowledge, it may not yield optimal recommendations, but the good thing is that it can provide explanations using the domain knowledge, and it don't need training data. They can recommend immediately. For example, if they see a metric, the catch hit ratio is low, or if you say some like metric, for example, your cache data ratio, you probably want to recommend increase your memory size. It's a very simple example, but you can provide explanation and it don't need training data. You can make run immediately. So in real world, you basically don't need to choose one. You can combine those two together. So for example, in first phase, you can use the heuristic approach that can, it's not ideal, but it's still good enough. And then and you can make random immediately. And after getting more training data, you can use the machine learning based approach to get to convert to optimal one. So basically you can use both, and you don't need to pick one. So another lesson is that it's not only a machine learning problem. So also at OtterTune we did is that is to how to apply those changes safely in the production database. It's not a machine learning problem. It's a product and engineering problem. So for example, all features I mentioned, not bound to need period schedule, or those are very. It's really not a machine learning problem, right? But it's really important for us to onboard customers, right? Because you need to make sure the process is safely on production database. So yeah, I think the last part I will talk about business, and we have 3 minutes, but this part is really interesting. So actually, our biggest change is not from technical side. It's from it's more from the business side. So one big change we face is that database tuning is not must-have thing. It's a good-to-have thing, nice-to-have thing rather than must-have. So in the VC term, it's a vitamin instead of the painkiller. So what does this mean? This means that our priority is low. So people show interested, but and they talk to us, but they often get put away by other higher priority tasks. And after 1 or 2 weeks, they talk to us again, and then if they have other high urgent tasks, they will just get back to them. So which means the cycle is really long for us, because it's not a must-have thing, right? Because it's good to have database tuning, but you can, but it's fine if you don't have that. So compared to database, it is a must-have thing, right? You need to set up Postgres, but you might not need the database automatic tuning. So that's the biggest change we face actually. So that makes our process long, and also we cannot scale really quickly because of that. Another thing is that it's really hard to make a product sticky. We try a lot of things, but many users just try our product for free, just tune in the first month, just tune their production databases, and they get most of the benefits, and they just walk away, right? It just really make it hard to make it sticky. When we raised fundings, the investor also asked the same question, right? How to make this product sticky? And we told them that their workloads is dynamic. They have new queries comes every time, so right? So you need to always use OtterTune. But actually, we still suffer from this. So dynamic workload cannot save us. Another thing is that deal size are limited. So even with large enterprises, they will just not pay us a lot. So for example, because our business is to save the DBA cost, right? Because it's auto DBA, right? But the thing is that for 1,000 MySQL instances, you have, for example, 5 engineers to manage them. But if you double your instance size, you probably still have 5 engineers or 6 engineers, right? Which means that it doesn't scale linearly with the size of data, with the scale. So even for very large customers with thousands of MySQL instances, you just have 5 or 6 engineers. If you save that one person, it's just, I don't know, $150K at most, right? So even our enterprise customers only willing to pay us a single DBA salary. This is the money we saved, which is $150,000. So it's really hard to make that have a big deal for large enterprise. So unlike the Snowflake, Databricks, Datadog, all the data companies, right? So the beauty of data companies is that their costs scale linearly or almost linearly with the size of the data. If you have like 1,000 instances, it costs you X dollars a month. If you have 2,000, just double that. So that's why they can charge a lot for the very large customers. So I know I mean, the dollars due for the Datadog, those cloud companies more than 50 million or even more, approach to 100 million for just one single customers. It's very hard very hard to achieve that at OtterTune, right? Because you cannot pay 100 million for the database tuning service, right? So yeah, so come back to this. I think the biggest lessons from this is that I think that's our cloud farmer saying, understand he's a very famous investor. So only thing that matters in startup is a great market. It's in a great market, and a market with lots of real potential customers, and the market will pull product out of the startup. So a great market means that you really build something people need. It's a must-have thing instead of the good-have thing. That's one big lesson from OtterTune. So come back to the original topic, that's machine learning work for databases. That is really working in the real world. I would say from technical side, it works. Because I think the performance we have, the numbers we have is actually better than we saw in the research. So from technical side, it works. But for startup side, I think it might not be a good business. That's just from our perspective. Through the OtterTune journey, it might not be a good business for startup. It might be a good business for the cloud provider, like for example, Amazon can do that, but it's really hard to a startup to do a business just for the database tuning. Yeah, so that's it. So if you have any interesting questions, feel reach out to me at openai.com. Sorry, not OtterTune. So here's my Twitter. Actually, this is our CEO, Andy Paolo. He just wore our OtterTune costume at Percona, I think. Right? Cool. Thank you. And feel free, if you have any questions, feel free to ask. Thank you. Yeah, I'll stay here. Yeah, I will be here all day. So.
Very, very direct one. So when you look at Postgres, MySQL, anything, we have the knobs, the settings, the variables, how we tune the database.
Mm-hmm.
We have the status metrics in MySQL. You have the same status in Postgres, which is the result of the workload you are running.
Mm-hmm.
We also have the OS metrics, which is the server,
Mm-hmm.
memory, I/O, and you have query performance or query execution time. So it's not so complicated to correlate all those.
Yes, that's right.
Points, right?
Yes.
What are the main settings in Postgres that you have seen cause most impact?
You mean use those of the metrics data? Was the most.
Yeah, because I think of it like, for example, we know that temporary tables, for example, if you increase the size the temporary table can live in memory, yeah, you increase the execution time. If that query was supposed to create a temporary table that moves to disk. But you also know that you cannot just increase that as high as you want because you risk going out of memory.
Yes. I think that's a very good point. I think that's what we try to do at OtterTune, because after collecting all the metric data with a metrics table, one good thing for Postgres is that they have very low-level metrics. For example, they have metrics for each table, and for each index is right. Yeah, we have lots of metrics, but at OtterTune we want to find a way to correct them together. So I think one biggest thing with our request from our customers is auto vacuum. So and I think there are multiple for debugging or improving auto vacuum. You need multiple metrics from multiple pieces. For example, you need to know the table metrics, the dive tuple, number of dive tuple, that tuples. Right. You also have auto vacuum activity metrics. And you also have the query metrics, because you want to do query to see whether there are non-running query or non-running transactions to block auto vacuum. And you also need to look at the knob settings, right, for those auto vacuum settings. And you also need to look at the database metrics. So I think that this is one example of how we create the metrics together. of auto vacuum because you basically need all the lots of the metrics metric from different places. I think the power of the auto tuning is that it's really like how you utilize those metrics and create them together. And I find that there are always opportunity there to improve that. So that's one example of auto vacuum. Another thing we find is that interesting part is probably query tuning, because for the query tuning you need query that plan those query metrics, and you can also create with the for example CPU those database CPU memory those database metrics, and you also can create it with the table schema and table metrics. Because if you are missing index and query, you can use table schema. So that's another example. You can create those metrics together. Yeah, so those are based on heuristic-based approaches. But for the machine learning, you just can put all the metrics to machine model, see what happens. But that means you need also training data. OtterTune is really hard for us to do that. But in a AWS, we can probably try that approach. There are several papers I can. If you are interested, I can talk with you later about using machine learning to do that. Yeah, question.
So you have on the auto tuning, I see a little bit of conflict in the terminology because it kind of defeats the purpose a little bit. You have your scheduling, you have human approval, which kind of defeats the auto
Yes.
part of it.
Yes.
But the question would be then, following up on that, once the changes are applied, does auto tune keep track of the performance and say, okay, performance is bad, let's roll back the changes?
Yes.
Without
I think because the startup is not there anymore, so probably I don't want to talk about OtterTune, but in reality, I think there's feature index tuning feature in Azure. They basically did what you said. So basically, I think you have index tuning feature, and you monitor those metrics to see whether they have degradation, and if yes, it just revert back. In real world, that's a really important feature for customers. Yeah. Cool. I think yeah, we have run out of time, but I'm here for all day. So yeah, if any questions, we can feel free to chat. Yeah. Thank you.